We're now going to program our inputs and outputs, and in this case we'll be having 3 switches. We'll be using those as inputs, controlling 3 outputs. Let's say you program the Arduino with these 3 switches and 3 LEDs to monitor the inputs, and we'll be executing different operations depending upon which button is pushed. We're going to cover some new Arduino commands, and those include the int variable example, a little different version of it than we used in the last module. We're going to add read digital pin, some logical conditions, which are known as if and else, and the various conditions we'll use in that if and else statements. And I'll show you an example, and then you're going to go build it in 3 parts. In the previous module we used the variable definition int to define which pin, and we're going to use it to define an integer variable or a storage location this time. We're going to be using the read digital, and that'll give us a value based on what the digital setting is, or the input value is of that digital pin. We'll look at the if structure and the if-else structure. In the variable definition, we did have that in the previous module, and we used it to assign pin numbers to names that were meaningful. And in this module we're going to use that same command to define a storage location for information. We'll be able to store ones and zeros or numbers, and we're going to start off with by storing ones and zeros. And we use that by, again, the int, int, a name for that integer. In this case I have an integer name of read value, and then I'm declaring it or defining it as an initial result of 0. In digital read, the format has digital read with the pin number in there, and I'll read a specified input pin and assign its value of 0 or 1 to the variable in the statement. For in this case, read value, which we defined previously in the int statement, is equal to a digital read of pin 5. So that statement there will read pin 5 and store its value in the variable read value. Once it's in there, you can use that over and over again until it's changed. Throughout the program you can continue to read it over and over, and it will stay at that value until you change it. Okay. The if and else statement, it's a nice control command that allows the Arduino to conditionally perform execution of one section of code or another. And in this case it'll go out and test something, for instance an input pin, and if that input pin state is true, then the first section of code is executed. If it happened that the input pin was false, the second section of code is executed. This is real nice. It allows you to do 2 different operations based on what the state of a sensor input is. They also have a simple if statement. It's very similar to the if-else. It's just that it tests the condition, and if it's true it will execute the code. If it's not true, nothing else happens. Here are some logical conditions that you can use when you're testing. X equal to Y. Notice here you have a double equal sign, and be careful with this. If you put one equal sign in there, the code will assign X to be equal to Y, and your code will not work like you expect it to be at all. So be careful with the double equal. It's very easy to miss that double equal and to put a single equal sign. Next line is X not equal to Y. The exclamation point is used as a not. Then you have X is less than Y, X is greater than Y, X is less than or equal to Y, and X is greater than or equal to Y. So you can see here you have a wide range of comparisons that you can do. We give you an example here. If pin val 1 is equal to 0, then you execute the commands between the two curly brackets. Otherwise, you go down to the else. In this case, pin val is not equal to 0, and you execute the second set of commands, which are between the curly brackets. So we're going to be building a program in 3 parts. And you'll build the first part, then the second part, and the third part, and test them at each time you go. The first requirement is to turn LED 1 on when button 1 is pushed, and off when button 1 is released. The requirement is to turn LED 2 on when button 2 is released, and off when the button 2 is pushed. Just the opposite of requirement number 1. And the third requirement, you will blink LED 3 on and off at a 50 millisecond rate while button 3 is pushed. So you'll want to start a new sketch, and the easiest way to do that is to save your previous sketch as a copy with a new name, so you can keep the structure of the setup and the declaration and the loop program in there, and give yourself a starting point rather than having to start from scratch. So you'll want to use the proper definition structure and define inputs and outputs, your button 1, 2, and 3 at pins 8, 9, and 10 respectively, and your LEDs 1, 2, and 3 at pins 2, 3, and 4 respectively. You will also need to create 3 variables for saving the states of the input pins. So let's build and test the first requirement, and that is turn LED 1 on when button 1 is pushed, and turn off when button 1 is released. You can do this by reading an input pin and saving the value. Read val is equal to read digital and then pin. Of course, you'll substitute the right names and everything here and the pin numbers, and you'll write that value out to the output pin. So write digital, the pin number, and whatever value it was that you read and stored into read val. So I've practically done requirement number 1 for you here, but you just need to put it in the proper format. Okay, so at this point you can pause the video, go off and build it, and then come back and compare your answer to what I did. Okay, first thing you should have done, is define all the pins. I happen to define the outputs first because they started with pin number 2, and then work my way up to my inputs there. Then I went ahead and defined variables. These were the names I used: read val _1, _2, _3. And then I did the setup. So for the output pins, LED 1, 2, and 3, I needed to set those as outputs. And so the buttons, I needed to set those as inputs. So button 1, 2, and 3 are all inputs. Then I wanted to set the default values of the LEDs and turn them all off to start. And you need to write a high to turn the LED off and a low to turn it on. So there are 3 statements there to turn all 3 LEDs off. Now here's the big code, all 2 lines of it, that'll take care of requirement number 1. Read val _1 is equal to digital read with the pin number button 1. So we go get the state, and then we turn around and write that back on out to digital write LED 1, and then the value contained in read val 1 to turn it on or off in this case. So if read val is a 0, the output at the digital write will be a 0 and turn it on. If read val is a 1, the output at digital write will be a 1 and turn it off. So how did you do on that? we're going to turn an LED number 2 on when button 2 is released and off when button 2 is pushed. This is just the opposite of requirement number 1. And this will be done with if/else statements. If button 2 returns a 0, then write a 1 to LED 2. Else, write a 0 to LED 2. The 1s and 0 can be replaced with high and low in your code, and add this code directly below the previous code that you did in requirement number 1. The definition, the setup are the same in the previous examples for requirement number 1, so no changes are needed. One of the things we do here is the LEDs are connected with their anodes to positive and cathodes to the Arduino. So to turn an LED on, the Arduino pin should be set to a 0 or low. And to turn the LED off, the Arduino pin should be set to a 1 or high. You can pause the video here and go build it. Refer back to the if-else statements, or go to the additional resources. You can click on that and that'll show you all the structure on an if-then-else with additional examples if you need to. And come back here and compare your answer to mine. Did you hit pause yet? Okay, here's the answer. Now the first part you'll see, the kind of orange color there, that's the requirement for part 1. The new code in white there is the requirement for part 2. Start off and I'll assign the value. Start off here and I'll assign the result from digital read of button 2 into read val underscore 2. Then I'll go test it. So if read val underscore 2 is equal to 0, which means the button's being pushed, we're going to turn the LED off, so we'll do a digital write to LED 2 and set it high. So that's going to be the opposite of what we read. Now if that was not true, if the read val 2 is equal to something other than 0, not equal to 0, we'll do the else statement. In that case, we're going to do a digital write to LED 2 with a low. So if we read a 1, then we're going to write a 0. That's it for part number 2. Hopefully you're right along here with me. Hopefully you're moving along fine here. Well, let's get to requirement number 3. You're going to toggle LED 3 on and off as long as button number 3 is pushed. It'll blink at a 50 millisecond on and 50 millisecond off rate, and this will repeat continuously. There will be no new variables needed for this. And this should be a simple statement where you go in and you test the condition of button 3, and if it is being pushed, you'll turn on LED 3 for 50 milliseconds, then turn it off for 50 milliseconds, and then complete the command and wait for the loop to come back and check again. You'll read button 3. Don't forget to save it to a variable. Then you'll test button 3 for it to be equal to 0. And if it's equal to 0, you'll turn LED 3 on, delay 50 milliseconds, turn LED 3 off, delay 50 milliseconds, and then return back to the main loop. Okay, now it's your turn to go off and build it. And come back and you compare your answer to mine. Don't forget to hit pause. I've got the original code that we have for requirements 1 and 2 up there in orange and kind of made small. Here's the new code. So I'm going to read button 3 with a digital read command and save its value in read val 3. And then I'm going to test read val 3 for it to be equal to 0. If it's equal to 0, it means the button is pushed. In that case, I'll do a digital write 2-pin LED 3 with a value of 0. Delay 50 milliseconds, Then do a digital write, the LED 3, to a value of 1, turns the LED off, and then delay another 50 milliseconds. Curly bracket here is the end of the if statement, and then the next one is the end of the loop, and it will continue looping like this continuously until we stop the Arduino. Now in the digital write statements, I have the pin number LED 3 and then 0, or the pin number LED 3 and 1, and you could easily replace that 0 and 1 with high and low. Okay, now that you've completed steps for 1, 2, and 3, a little time for a challenge. Why don't you go and play with the inputs and outputs and see if you can do the following. Using one switch, turn on an LED to follow the switch like we did in requirement 1, and then blink a second LED while that same switch is pushed, which would be combining requirements 1 and 3 with a single push button. So that's one input controlling two outputs. Then go turn on an LED if two switches are both closed. So for instance, if switch 1 is closed and switch 2 is closed, then your output will be on. So this is two inputs controlling one output, and you can go off there and say read button 1 and button 2, and if both of those are pushed, then turn the LED 1 on.